Okay, in this lesson we're going to look at the critical attributes of a linear function or graph. And what I want you to think about especially is how we interpret those critical attributes. What do those critical attributes tell us about the real world situations? Okay, now the specific critical attributes we're talking about slope or rate of change, and we might add to this in just a second. We're talking about slope and rate of change. We're talking about the y-intercept. We're talking about the x-intercept. And I do really important want you to know that another name for the x-intercept is the zero. If it asks you to find the zero of the graph, or the zeros, well, because there will be some types of functions that have more than one, a zero is referring to the x-intercept. We also need to know if our graph is continuous or discrete, if it's going to make a line, and things like that. But these are the main attributes that we're going to be talking about. And so we might add to this list to talk about kind of what it might mean to help you answer this central question. Okay, so let's look at this example. So the first thing it says is determine the slope of the line. What two methods can we use to determine the slope? And so there's lots of different ways we can kind of look at that. I think everyone knows that we could do the rise over the run. So we could draw a right triangle. So we could draw a right triangle and do rise over run. You also could write down the coordinates. So like this coordinate is 0, 5, and this coordinate is 5, 0. So you could use the slope formula in order to do that. Okay, so I hope you're thinking right now, what kind of slope is this? And I hope you're thinking that this is a negative slope because it's falling to the right. If we drew a right triangle, this is going to be a rise of 5 and a run of 5. And so that makes our slope negative 1. And we would get the same result if we used the formula. Okay. Now it says, what does the slope of this line represent? As you work on your assignment today, I'm going to ask you to tell me what is the slope and what does it mean in terms of the problem. So this is where we're going and putting our labels with it. So if we look at what is on our y-axis, it says gallons of water, and our time is in hours. So this slope, we could say, is -1 gallons per hour. Or we could even put words with that and say that, maybe this is, we're pumping water out of a pool, or something has a leak. We could say that it's losing 1 gallon of water per hour. Okay, so when I ask what it means, what it represents, I'm saying in terms of our situation and our problem. Okay? The next one, what is the y-intercept? Remember, we talked about y-intercept is the point where the graph crosses the y-axis. Here is our y-intercept. And so the y-intercept is 5. Well, what does it mean? What does that mean in terms of our water and our time? And so we could say that we start with 5 gallons of water. Or we could say at 0 hours we have 5 gallons. And so that kind of refers me back to the y-intercept here. Remember, this is thinking about maybe a starting amount, what we start with. The rate of change is basically a rate that we're talking about. Okay, so the next one says, what is our x-intercept, or our 0, and what does it represent? Remember, x-intercept is where the graph crosses the x-axis. And so our x-intercept there is also happens to be 5. But this means something a little bit different, because at this point, the x, 5, represents time, and the 0 represents gallons. So we could say after 5 hours, there is no water. All the water's gone, right? If this was a tank, the tank would be empty, or if a bucket or whatever. Okay, now let's talk about if we change our attributes, how would this make the graph look? So it says if the bucket began with 10 gallons of water, how would the graph change? Okay, so let's think about that. So that's going to move my graph way up here, right? So it's going to move my graph up here. And so what is that going to change? Is it just going to shift it up, or is it going to change the steepness? What's going to happen? And so what you should say is you should notice we still have the same rate. So what we would see is that the steepness is the same. The graph moves up, right? The graph moves up. The steepness stays the same. We could also say it would take longer to empty the bucket, which means our x-intercept would be different, right? Okay. Then it says if the bucket lost water at 2 gallons an hour, how would the graph change? So if it's 2 gallons an hour, what are we changing? We're changing the slope, or the rate of change, right? And would that mean that our graph would be steeper or less steep? Steeper or less steep? So think about that. If you're losing it, originally we were losing it at 1 gallon per hour. Now we're losing it at 2 gallons per hour. So I could even graph this. If we're starting at 5, down to over 1, down to over 1, down to over 1. So look, that's what our new graph might look like. And notice that is a steeper graph. The graph is steeper. So even though we're losing, even though it's a negative slope, if we think about its absolute value, it's still creating a steeper graph. Okay, so let's look at the next problem. Read it to yourself. And it says, use the cost data from the table to create a graph. So we're just I'm going to take these points and I'm going to roughly graph them. So let's see, this would be 30, right? So 1, maybe about right here. 3, 42.50. 4, 50. 7, 72, and I really, it goes way off the graph, right? 9, 87, so about right there. Okay, so I just plotted those points that I see. Now, don't get in a hurry to connect this, because we need to talk about this. It says, should the graph be continuous or should it be discrete? So we're talking about the number of hours and the cost to hire them. And so what do you think? Do you think they're going to charge us for amounts in between? Do you think they're going to just charge us by the hour? I'm going to guess that they probably are. I can see an argument for continuous, but I am going to say that this graph is discrete, which means we would not want to connect these points. Okay, so then let's talk about the domain. What's going to be the domain for this situation? So it said that, let's see, x represents what? The number of hours. So the lowest number of hours that it could be would be 0, even though that's not in our table. It could be 0. It could be 1. It could be 2 hours, 3 hours. In that pattern, all the way to what? Okay, well, it said that that Lons R Us will only work for a maximum of 10 hours, so it would only be up to 10. And so that would be our limit. And then for our range, that's going to be the cost. So for 0 hours, they're going to charge us that flat fee, that initial amount of $20. And then we're going to be increasing in increments of 7.5. So for 1 hour, it would be $27.50. For 2 hours, it would be $35, on and on and on, up to 10 hours, where in 10 hours would be $95. Okay. What does the rate of change represent in this situation? So if we look at our equation, we see that our rate of change is 7.5, or it would be $7.50 per hour. So the rate of change represents that Lons R Us charges $7.50 per hour. So that kind of gives you an idea of how you should be interpreting your word problems.